Welcome back. In this video I'll be showcasing a player inventory storage system that allows me to copy a player's inventory so I can give it back to them later. Now this uses a few systems and I'm quickly going to showcase it. Let's go ahead and store my inventory away and let's clear my inventory, and then let's go ahead and do restore. And as you can see, my inventory is back to the way it was. Now this will copy all of my inventory. My ender chest is not copied by this because I don't need to, but I can if I want to. So let's go ahead and take a look at how this works, as well as a little bit of an example of my memory storage system. So first off, let's go ahead and trigger a write data here. And let's get rid of that. And then let's go ahead and clear my inventory once again. Let's clear my inventory again. And let's grab these items and let's go ahead and put them on. We're just going to sort of let everything be how it is here. And then we are going to go ahead and do another store. And then we are going to write again. Now what I can do is I can trigger and read data, and I can read from slot 1. And then let's go ahead and restore my inventory again. And as you can see, we have the same inventory that I had at the beginning of the video. And then let's go ahead and read slot 2, and let's do a restore again, and we have this here again. So I can effectively go through and just have any amount of inventories I want that I can store within my data storage system. I'm using this one right here just for ease of use, but I can use my single block based one as well. Let's go ahead and switch over to the functions and take a look at how this works. So right here is the first function. What we're doing is we are copying first of all, we're making some namespace within my RAM system right here. And then we are copying the player's inventory tag into another array that I have within my RAM address for the storage system. This can be really wherever you want to store it, but for example purposes I am using my data storage systems. And then once we're done here, we are running this interpret function. Now this interpret function will run a slot detect, and then it will recurse until there is no longer any more objects within the player inventory array. So let's go ahead and look at the slot detect. What this does is it will store a result of the slot data. So right here, it will store this information here from the player inventory array, which is just the inventory data from the player directly. And then what I'm doing is I am copying it into a score, as you can see here. And then once I'm doing that, I then, based on what that number is, I run a set of different functions, and then I remove the object at the first position within that array, at which point this would then run through again, and this will keep going until it runs out of objects to search. Now these right here all run different sets of information. The hotbar one is the most simple, because if that slot is 0 through 8, all it does is copy the object directly into the slot's hotbar array that I have within my storage thing here. As you can see, I have player inventory, which is the array. This is what the player's actual inventory data gets copied into. And then right here is all of the objects that have their arrays in them. There's hotbar, inventory, armor, and offhand. And that is what these go through: hotbar, inventory, armor, and offhand. So right here, this is the most basic one because it doesn't have to do any interpretation with the slot value. But then whenever I get to, let's say, the inventory, I have to remove 9 because that is the lowest possible value for an object that is within the player's inventory. So if we look at the player's inventory right here, this is slot 9, this is slot 10, this would be slot 35. So what we want is for this to be slot 0 and this to be slot 26. So what we're doing is we're removing 9 because this is 0 through 8, the first 9. For the hotbar, we do not have to change any of these values. We only have to change the inventory and the armor, which we remove 100 because the armor in order from feet to head is 100, 101, 102, and 103. Then we are doing a similar thing for the offhand. We are setting the slot to 0 because it is negative 106, as you can see right here. If it matches negative 106, it runs the offhand. If it's 100 through 103, it runs the armor. Inventory at 9 through 35, and 0 through 8 for hotbar. Now that is the interpretation and the storing of the data. Now once all that happens, what I am doing is I can then store it and do that, but I am then running a restore function right here. Now this restore function works by running a loot command. Now this entire system is dependent on a loot table. This loot table to be specific. This is a shulker box loot table, and this will take the contents of that shulker box and place it directly into the inventory with a one-to-one data translation, including slot tags from the shulker box. And since shulker boxes do have data verification, you cannot just simply copy all information directly. You have to have proper inventory formatting, or else it will error out and start deleting objects. And for the hotbar, all I'm doing is doing a replace entity at hotbar 0. Now this will take the inventory. Let's go ahead and switch over and look at our shulker box. As you can see, we have 64 arrows because that is what was in my offhand at that time, and the offhand is the last one we run. But essentially what happens is the data from the inventory that we're copying from, let's go back to our thing. Whoops, I just blacked out my Minecraft there. What we're doing is we are copying the information, as you can see right here, from the slots directly into that shulker box that is at this position. And then we are looting that to replace the hotbar. And then for the offhand, we're just placing it in the offhand. For the inventory, we're placing it in the inventory. And for armor, we're placing it in armor.feet. And there's a more in-depth explanation on this on the Minecraft Fi GitHub, which you can look up and see everything on. I am just implementing all of them to a simple system that interprets all the data itself. So hopefully that makes sense. That is everything there is about this system and everything that my specific idea here does. I'm not the first one to do this. A friend of mine made a system that did this yesterday. I just sort of went through and made my own that would work with my memory storage system. So yeah, thanks for watching, and I will catch y'all next time.